dark. We used to turn on the light.
Yeah, you're the dark.
Oh, well, I don't know. Maybe like this, nobody recognized me in the video.
Exactly. It's good against the NSA. Then you can figure out if you're...
I have so much hair as well. But yeah, a bit, but not much.
Well, I guess I can hand over straight to you, right? So welcome everyone, thanks for coming, but I don't have actually much to tell because the guy who worked is Miguel, so.
Work a bit, I did much less than I would like, as always. But yeah, I can show a bit the progress since last time we talked, which was a while already. Time flies. Dieter, can you give me the rights to share?
You don't have it?
Nope.
Ooh. Security, is it here? Yes, share screen. Yeah, you should be able to do now.
Okay, I think I'm going to move you over there. Yeah, so if you are in the channel in Software Underground, I guess that you get the annoying notifications every time I'm pushing something to main. So you have seen that has been some activity. So yeah, what I did. So last time when we talked, we were a bit more in the conceptual space yet. So we had decided to try to create these data structures that they were building from the memory, adding some geometries all the way to more open metadata. So we were always having in mind to use X-array at least for an structural data. So one thing that changed a bit because Bain was talking with the people of X-array is that they said that we could use it as well for the unstructured data. So at the moment, what subsurface is becoming is basically a wrapper around X-array to be able to construct a bit more complex data objects than just NumPy arrays. And then all the readers and writers. So this is the documentation. So I was just doing a bit the typical template of the library that we were missing. So now we have already the docs with Sphinx, with the usual that we expect from a Python project. The documentation is completely empty. So I was just making the skeleton, hoping that all of you go and fill it. At least I did the getting started, just to give a bit of a feeling. But and there's other thing that has evolved quite a bit in the last 4 or 5 months is that we started to have a bunch of readers of different formats. So, for example, Wells. So Wells, I'm using pretty much Welly to read the files. So first I'm parsing it with Welly, and once it's in a Welly data object, I write the netcdf. So these are a bunch of functions just to read Wells to unstruct, because borehole data is a line, so it's unstructured data. So this is this unstructured data. So in the end, every object in subsurface is either unstructured data or structured data. From one of these, we can just go to the next step, which is these elements. So in the case of boreholes, it's a line set. And here you can just imagine that this is at the PyVista level. And actually from the Wells element, we can just, in one function, create the PyVista mesh and start visualizing it. So we have, and that is basically what I'm focusing at the moment. We have this bottom level with unstructured data that is X-array data set with a constructor and a bit of a properties, but not much more. And then from there we go to the elements, which we can just visualize in PyVista, for example. So the next level, that is when we say, okay, so if it's a plane can be a fault plane, and then the level even after. So if it's a fault plane, who is the person who took the data, which day and in which company, all of that I'm not doing anything. And I'm not planning to do anything. And I'm also thinking that I don't know if we really want to do that in subsurface, or it's a completely different story for how we merge this with open mining format or things like that. I don't know. So I'm open to anything. I don't mind.
So everything is an X array now.
Yeah.
So then anyone could, as long as we are sure that all the attributes are passed as well, anyone can put into the attributes whatever metadata they want, right? Like.
Exactly. So in the end, for example, open mining format, normally they have one field, which is an NumPy array. So because of that, I imagine that they have to have many fields for many data NumPy arrays that represent different stuff. By using these, they could simplify a bit. So they have like the all geometric data is this subsurface object and contains all the vertices and cells and attributes. So I can show you later how unstructured data and structured data looks like. But yes, it's a data set of X-array. Because an X-array, they have this data array, and then they have data sets that there is like a dictionary of X-arrays. So it's a data set, to be exactly. Yes, so this is a reader for showing that with points is very similar. So are just the colors of the boreholes. So we get unstructured data in the same way as before, but now they represent a point set instead of a line set. Again, from the point set, we can in one function create the PyVista mesh. We can visualize. So this is pretty much the idea. So the topography, instead of being unstructured, is structured data. So the parser writes unstructured data, but it's still an X-array data set. And from there, we can go to the higher element, which is a structured grid. From the structured grid, we can go to the PyVista mesh, visualize. Profiles is an interesting one, because this is, we have an unstructured data for the location of the profile, and then we have a structured data set for the texture, because that is always the same amount of pixels. So here we are, I mean, they're a bit hidden in these functions, but in the end, we are just creating an unstructured data set and a structured data set, and then we just pass it to the element, which is this triangular surface, and the element take both to be able to just create this in PyVista. Here it was me just exporting GenPy. And the good thing of NetCDF is that in the end it's a very well-defined type. And so you can write it in disk in one file, you can convert it in binary and send to a different language and read it there. So
yes, with the exception that there is no native complex data support.
What do you mean?
Which always beats me a bit. NetCDF cannot store complex data.
Oh.
You have to break it apart into real and imaginary part.
The EM guy is talking. Miguel is like, oh, EM, complex number, what?
When do you want that?
All the time, every day.
I know. There we go.
Okay, but those are two columns, so it's not that difficult. Okay.
Yes. Yeah, you just have to decompose them.
Yeah.
Yeah, I guess it's a good question, Dieter. How are you going to deal with it? I'm just going to save two arrays and then flag it as being complex, and reform it after. Or?
I guess we should just follow in the NetCDF help. There is a way how they suggest to work around.
Okay.
And I guess we should just.
Someone else does that. Yeah. Okay.
Well, the question came up a lot of times, but NetCDF is still dominated by climate meteorological guys, and they are like, Miguel, why would you want to have complex data? And so, yeah.
That sounds really complex. I don't know.
No pun intended.
Yeah, but so the structured data and also the unstructured. So one thing I was doing today is just refactoring the constructors, because in Python you cannot do overloading of constructors, and at the moment it's a bit of a mess. But I found that with class methods you can get somewhere there. But in the end you have this data that is a data set, an X-array data set, and then you have all the logic to do the construction so that you can get there with NumPy arrays or directly passing the X-arrays or passing some bunch of dictionaries, and then you have a couple of properties. So it's just a glorified data set. But that's pretty much it. So, I mean, in test, we have a couple of more formats. So if you run the test, you can see, these are, I mean, because we are reading the wells with Welly, we can get also the logs, for example. So this is, you could see it in the notebook. We have also a parser for seg.y. So we have a bunch of examples already. And again, all the parsers, they always read first to either unstructured or structured data and then the rest. Mm-hmm. Then for Dom, that he wanted to have more general data associated with these things. So this is not documented anywhere, but I use it already for one of our projects. And it's that in X-array, they have these X-array attributes that is really a dictionary attached to the data set. So, and that can have any format. So if you have the structured data and then you just want to pass a bunch of fields that doesn't fit with anything, you can always just attach it there. So
that's
yeah,
right.
That's it, the situation now. So I don't have much more to tell.
Oh, I mean, that's a lot of work. So you've in terms of dependencies, will basically all the packages that have IOs are going to have to be added as requirements, right? For subsurface?
Optional requirements. So my idea is that the requirements try to keep it as light as possible. So at the moment is X-array, pandas, and NumPy.
Nice, yeah.
Because in case that you want to just use the structure itself, so if you don't want to read from disk, you want it to be super light.
Yeah, exactly.
So the idea is to have it really, really light, and then whenever you want to read something specific thing, you install it. So even PyVista is optional, because you don't need that if you don't have to use it. But yeah.
You're not importing the hookups to PyVista right away. You only do it on demand. Is that the idea?
Yes.
Let's say for your PyVista, can I see your? I guess I can read it, but that's the PyVista part. Yeah.
So test visualization, test PyVista.
So you only do it there.
Right. So basically, we just create it from. So a point set, as I mentioned, you just created unstructured data. From the unstructured data, you create this point set, which they are also ridiculously light at the moment. So it's the constructor and a couple of properties. And then here to PyVista is where we just select vertex, attributes, and this is already a PyVista mesh that you can combine in the plotter. So the idea is always having very well defined the hierarchy of data, and so for talking between the different libraries, technically we could choose in which level we would like to export from GenPy and importing in Simpect. For me, since the most important thing is always the data, what we are sending around is that. Also, we are building serverless service. So for sending all these data sets over the wire over the internet, the best thing that you can do is just go here to the netcdf and make binary out of it and send it around. So I'm a big fan of having this the very low
PyVista plotting might be different, but like Simpeg or Verde or other packages, we sort of agreed that they have to implement it, right? It wouldn't live in subsurface. Or how do you see it?
So ideally, all these libraries, they will have subsurface as dependency. Yeah?
Yes, but no code in subsurface. Like
no, I think that is not necessary. So
exactly.
When we were talking in October, we had these module interfaces just in case that someone wants to export from subsurface to something else, but always with the idea that should be the other way around. It should be something else using subsurface. And actually it's completely empty at the moment. Nobody's adding there anything.
No, but you are already doing it, aren't you? You're already like creating a PyVista object inside subsurface, aren't you?
That's true.
Oh no, you've just done it inside the code, inside the.
No, but PyVista is like the exception. So PyVista is really in subsurface just because of the visualization. So the thing is that to be
that
sure,
might also change if it gets into PyVista, then it's not necessarily that it's in both, right?
No, so the main reason why it's in subsurface is just sanity check. So when you import anything, you want to plot it, yes. So it's an optional dependency. You don't have to use it, but
got it.
But that's.
So we need on our side to be able to read and write to subsurface format. That's the idea, yeah.
Exactly.
Okay.
So the idea will be, so for example, in GenPy, maybe I can even show you. I think I have it here. In GenPy, I did it for the output of GenPy because it was like too obvious, not too. Yeah, it's not too pretty to go through. but normally, so GenPy just generate a bunch of NumPy arrays with the values of each voxel. So before they were literally, it was the solution, it was a class with a bunch of fields that they were NumPy arrays. So from that, you can really just create one single subsurface structure data object in this case, because it's in a regular grid. If you want, for example, the meshes, there will be a couple of unstructured data objects. In there, you can always decide if you really just want a huge file or dividing it in a couple of files. But for example, to save in disk, the solution, this is the easiest by far. Otherwise, you really need to, you always need to write in disk a bunch of NumPy arrays and then somehow remember what was the name of each of the NumPy arrays and which they represented. In this case, once you put it in the netcdf, you can just say to disk and you can load it and you have there all the output of GenPy. So
Miguel, I have one small question. So I'm seeing the structured data class, and why did you choose to, I mean, as far as I can see it, it's just a container for X-array datasets, right?
Mm-hmm.
So is there a reason why creating a class that will just contain a dataset? Or why not use it like a dataset accessor for defining some special methods?
Well, just because I don't like object-oriented, that would be the short answer. But yes, so the structured data is pretty much a boring data set. The unstructured one is a bit more interesting because you always have the X-array that contains the vertices, the X-array that contains the cells that says you how the vertices are connected. So it's a data set that the different X-arrays depend on the other, let's say. So in the unstructured data makes a lot of sense to have our own class that creates our own X-array data set, because they are a very specific data set. For structured data, it's a bit just to be consistent and having the two classes in subsurface and so on. So.
And you said in the beginning that Bain talked to the X-array devs, and that we could also use X-array for unstructured data. And what? And I'm sure there are good reasons for it. But what could you maybe point out? What would be the main advantage in comparison to the original idea of having like NumPy arrays for the vertices and for the cell connections? And just out of curiosity, I'm not saying that move back to NumPy arrays, but just
there is not much. So
okay.
To be honest,
well,
so originally, sorry,
X-array is a NumPy array with extra things, but
exactly.
if you have the X-array and then make a dot values, then you have the NumPy array.
Yeah,
I guess it was more for consistency if everything is in the same.
A lot was so that. So the original idea, also for the people who were not in the previous meeting, was that for the unstructured data, we were going to need an object that represents the vertices, an object that represents the cells, an object that represents the attributes of the cells, and an object that represents the attributes of the vertices. But technically, they could be all either NumPy arrays or pandas data frames. And yes, true. So now it's an X-array. They are 2D X-arrays for the most part. So they could be a pandas data frame instead to be an X-array. But actually, when I export the output of GenPy, it was useful.
Yeah, it's ND, it's any dimension, but any X-array you can make also a 2 data frame, and then you get a pandas out of it. So a flattened version.
That's a bit the thing, and I don't know how much we should try to force the users to say, okay, you should always create one object, or you should do the divisions of dimensions here or there. I mean, in the end, it's going to be a bit out of preferences of if you are going to have 2 subsurface objects, or you want to just create one subsurface object with 10 dimensions. That's
yeah, I think you talked about pandas, and then because there's also GeoPandas, or what is it called? And X-array, but then pandas is really, they even deprecated the 3D stuff and they limit to 2D. X-arrays for NDs, and NumPy arrays are probably the easiest and fastest, but don't have the labeling and the fancy slicing and selection.
Right.
I think
actually GeoPandas has to do quite a lot with the stuff that we are trying to do here, because in GeoPandas they have this column in the data frame that contains geometric data, and the geometric data in the end is vertices and cells.
Yeah.
So they are their own specific objects for each stuff. So it's like element for the terminology that we are using here, and they are attaching the element into a data frame, which in this case will be the attribute data frame. So in GeoPandas they have very similar ideas, but instead doing this thing of 4 X-arrays or 4 data arrays to be consistent with the naming, they just try to put everything in a 2D data frame. I think that this is a bit more general. It's a bit more mathematical, if you will, because in the end, everything are matrices, numerical matrices, and not much more.
Let me quick. You see the screen?
Mm-hmm.
So this is from last year, from the hackathon, where we had this Fatianda to GenPy, GenPy to PyGimli, by different contributors. Petrel to, well, with Petrel it's probably a bit more difficult. But you think this year we could try to do these things through subsurface? You think it would be ready to try and hack around that?
I think so. And I think that the hackathon would be perfect because then
like
we are
do
going
a
to be
GeoSci to
around.
PyGimli test, implement it in PyGimli and in Simpeg and move it around. Fatiando.
I mean, the cool thing of this is that if we do GeoSci to subsurface, Dominic does subsurface to Simpeg, Florian does PyGimli to subsurface, then we have everything already.
Yes.
It's everything connected.
Yeah, just need. Yeah.
That would be pretty cool. I really think that we should try to give it a go to that.
Cool. I mean, yeah, that would be then almost a year-long hackathon. Well, with mainly Miguel in it, but anyway. Yeah.
Actually, they started in the first Transform 2 years ago.
2019 in France. Yeah, that's true.
Almost the only thing that is still
alive. The journal is a bit on a low burner at the moment. Yeah. Cool. That's exciting. And you said everything works. So you have well logs, you have unstructured meshes, you have structured meshes.
Yep.
So that should also work for cylindrical meshes, right, Tom? Then.
Yeah, I'm not the pro of cylindrical meshes, but we'll look at it. There's so many objects in Simpeg that would be good to have a way to can them and to look at them all and see how they all fit in.
Because then it would also be interesting to see with the octree that is structurally unstructured, or however you want to call it.
Yeah, but the indexing is a structured array technically, right? It's just the octree level and the address. So it's a structured array. Yeah.
Yeah. So in the end, it's just another building block. I don't know. So sometimes you have the feeling that doesn't add much to just be passing NumPy arrays around. On the other hand, I really think that it does. At least for us, for the work that we are doing,
it's partly the selection with names, and because partly if you get a lot of data in, let's say you then have different layers and things like this. So you don't just have to use index, but you can use actual names, say.
Yeah, exactly.
First iteration, second iteration, starting model, for instance, in inversion. It just becomes, and I think it's also the main purpose of Xarray, the labeling, that things have a name and not just a number.
The NumPy records are good, but man, they're hard to slice. I don't know why it's so hard to slice.
Yeah.
It's not intuitive to slice NumPy as well. Question, Miguel, you originally said that the X-ray were data sets. Like it was an X-ray data set.
Can you repeat that? The connection is a bit.
Sorry, my connection isn't been that good. Can you hear me now?
Yes, talk very slow and clear. Yes.
Okay, that's hard. Okay, originally said the X-ray was a data set.
Mm-hmm.
So from there, the various arrays are stored, and then we can do NumPy. We can transform it into NumPy, right, with the dot NumPy.
Yes, I don't know if you have looked to these X-arrays, but these X-arrays basically, if you have been playing with pandas, they are literally pandas, multidimensional pandas, data frames. Actually dealing with this thing, there is a few changes. So pandas stores every column as an individual NumPy array. X-array stores the full multidimensional matrix all together in memory. So when you are slicing in pandas, they are just putting everything together as you are asking, while in X-array is basically the other process. They just cut the memory and do the copy.
But it also has lazy loading, so you don't have to have necessarily everything in memory.
Right.
If you get a big data set.
Yeah, so the main reason why I ended up with this is that basically pandas stores everything in C order, except when you extract multiple, that then is in Fortran order. It was a bit of a pain in the ass when I was writing binary out of it. Anyway, that is technical stuff.
So I know that X has a powerful metadata, can put a lot of attributes. I've seen X-ray that are just the data store endless in all of the information that it has. Are there going to be any conventions on how much
Any what,
or
sorry?
any information on the X-ray? Like how many or any conventions? Is it hard to hear?
Yes, very hard to hear.
Yeah, let's just cut our video feed. Guys, gonna help out, Andrew.
Okay, we can
It's
try.
okay. I'll ask through Slack. Oh, hello.
Yeah,
we're
you can
good.
just
Go for it.
Okay. Okay, can you hear me?
Yep.
I hope so.
Okay. So my question is, in X-ray, it has a pretty powerful metadata. It has a lot of information on like how many attributes and everything that you have.
right.
I was wondering if we have a convention, how much information to provide.
Yes. Yes. So the X-arrays, they have the data, that is the multidimensional NumPy array. Then they have the coordinates. Then they have the dimension, that is the name of each axis, let's say. Then they have the coordinates, that is the name of each element in the axis. And then they have these attributes, that is a arbitrary dictionary that they attach there. So in general, these unstructured data and structured data, they have already defined the first two. So basically, the number of dimensions and the data, let's say. So the name of the dimensions. So for the unstructured data, we have the vertex X array, which has two dimensions, one with X, Y, Z, so basically the coordinates, and the other dimension has, I don't know how we call them, points or something like that, but it's each individual point of the vertices. For the cells, very similar stuff. So they have the columns, that is how many columns defines how big are your elements, but has to have one column, and then all the entries, that is the number of elements that you have. And then with attributes, it's a bit more free, but not much, because in the end you are going to have one X array that has to have pretty much the same shape as the cells. So the number of cells has to be the same as the number of attributes, and then you can have many columns. So if you have porosity and then permeability or whatever properties you want, that the user can define. But so yeah, in general, the geometry, that is pretty well defined in the X-array or in the subsurface objects. So they have flexibility of how many properties you have and how complex are your elements, but they have to have a very specific thing, that is the. Is people still hearing me? Anyways, it's a bit. That's impressive, because it's quite tricky to explain without showing an example. But
yeah, I've seen. I worked with X-ray before, but I just wanted to know how it looked like with all of the different elements.
So and then what we are doing here is trying to think, okay, how many X-arrays we need to be able to define any geometry in a space.
Mm-hmm.
And that is basically these four X-array. So vertices, cells, attributes for the cells, and attributes for the vertices. And that is all what we are doing here, nothing else. And it's very similar to VTK. I mean, we are not the first ones inventing graphics now. But we are just putting it in with X-arrays.
Great, thank you.
Do you foresee? Sorry, go ahead.
Yeah, I was about to say that I would like to get Fatiano more involved in the project, trying to use subsurface. So this is quite a good timing because in the past few months, we were trying to design some better stuff for defining layers of prisms and tesserates that we often use for example, terrain corrections, or when we do, for example, MOHO inversions, we just, instead of inverting the densities, we invert the geometries of the tesserates. And for that, we used to define like a prism of tesserates, but that was a special class that in the old Fatiando library in the 0.5. But now in Harmonica, we decided to try to avoid defining these container classes that just stores data, because we were afraid that in the future, if you change that class, any old class you have stored in this may not function well. And yeah, we don't want to spend too much computer time, and in the future you cannot open the output, right? So we decided to stick with Xarray and store data in netcdf as default. So the entire Verde landscape is like start with scattered data or point sets that would be in subsurface and produce two-dimensional grids so far. Verde currently works only with 2D so far. And so in Harmonica, currently we have griders, especially for equivalent layer griders, and they work the same. They produce two-dimensional grids out of scattered data with a small plus that we also have the height of the observation of the gravity or magnetic observation. So I think that process, it's almost done. I mean, the work for trying to make Verde and Harmonica compatible with subsurface is almost done, because we are already producing X-arrays data sets. But I would like to try to think about the input, like how we could create some functions, for example, for getting the point sets classes from subsurface to how we manage scattered points in Verde especially. And also I would like to think how we could use the unstructured data for the prisms layers, because I'm designing it now. I have an open PR in Harmonica I can share. So it's just an X-array with the thing that I obtained. I assume that the prisms are of equal size. So I take the length of the dimensions of each prisms by the distance from its center, from this its center to the next one, right? But I don't know if that's, I mean, it saves memory, but I don't know if it's, I mean, in the future, if we want to implement meshes or something more complex, would be not optimal. So from the Fatiando perspective, I think that's the most work to be done. And I don't know if you have any ideas for that, or want to share something.
No, so what I think is that all of us, we are working with exactly the same type of data, in they are numbers, and in Python specifically, normally they are NumPy arrays, and we do different collections of NumPy arrays. So yeah.
Have you already an example with a finite element, like for PyGimli, or that would be similar to tesseroids, right? Did you already, just out of interest, if you already did one, Miguel, and a mesh?
So for what? Sorry, for
an unstructured mesh?
No. So okay. So complex tetrahedron meshes, I didn't do, no.
So that was something we could work on during the hackathon. Yeah.
I mean, in the end, that is more at the element level. So you're going to have an structure X-array or several, I don't know. That's something that we have to think. And then we will just create an element that combines a bunch of unstructured and structured data objects to create something more complex. but definitely that's something we have to work in. I mean, in the end, I think that what the ideal case that we need here, it will be a bunch of constructors of these classes, so that you can just end up in this unstructured or structured data from the very different places. The same with the parsers, and so you being able to read different formats, and then with multiple constructors, but we always end up with these base data structures, and then see how we can combine those into some more complex elements like tetrahedrons or lines. But if we are able to, I really think that there are not so many cases. I really think that there are infinite possibilities of how you manage memory to do those things. But in the end, the number of things that we have to do, there are not so many. But during the hackathon, I'm quite flexible to be working on this stuff pretty much the 2 weeks. So I don't know how long the mat has it, but would be really cool if we just make a gather room or something and we just discuss the different problems. I would be really happy to support everyone.
Bring in any suggestion today. In about 3 hours, you have the next meeting. But the hackathon is probably less long. It's probably Friday, Saturday, Sunday.
Mm-hmm.
And then during the week as you want, and then the finish before the last weekend, because that was kind of, yeah, it kind of got a bit lost last year with the second weekend. So it's probably mainly the first weekend. And then I think project presentation, I think we said something like Thursday or Friday during the day. So it would fit for Europe and America at least. But we'll see. Yeah, something like that.
I think it's good. So if because last year there were many days, but nobody was really working all the days. Yeah. If we really spend 2 days just looking at this, it's a lot of time.
Yes. Exactly.
One thing that isn't fully clear to me is like, so what would be your take on visualization? So you said that PyVista has a special role because we need visualization for sanity checks, and I fully agree. But then all the other libraries that also work in 3D, they will also like or already do 3D visualizations of cell-based data, maybe also point-based data, or streamlines for fields. And so would it also be a common goal to have subsurface also as a joint visualization layer, or would this visualization be really just for sanity check and everything else is up to the libraries? Because we at the moment we had one PhD student who started with this PyVista wrapper, and we had this nice show command which opened a little Qt window and you could slice around the unstructured 3D meshes, and it was really cool. And then now he left and it doesn't work anymore with the newest PyVista library, and I didn't have the time to look into it, and nobody else is working on anything in 3D at the moment. So it's a bit at a point where we are discussing if it makes sense to prolong this PyVista wrapper, or if we just make a nice subsurface interface and then we just do visualization with subsurface.
I'm not going to do it. That's the short answer.
That was not my question. But
for me, it's really just for sanity check, because I mean, in the end, I don't know.
I guess we could leave it open. Yeah, if someone, as long as it's contained, like now you have, what is it called now? 2 PyVista.
Yeah.
In visualization, so nothing would speak against to have their other files, right? If someone does it.
So the thing is that in the visualization realm is happening a bit the same as in data. That in the end, we all want to visualize the same thing, but there is endless way to play with memory for doing that. Because one thing that is in my head since a while is to take all the visualization of GenPy and take it out to its own project as well. Because in the end, it's just visualizing geological data, but actually it's very similar to what Vein has done with PVG already. So if we go now to subsurface and we start building again functionality on top of PyVista, is a third one that is trying to be PyVista for geologists. So
yeah, and the issue with that is that we need to keep track of their changes, and it's like in a big dependency to have. It's a lot of work. It would be better if they maintained, you know, the examples or whatever on the PyVista side where things are happening.
It's actually, yes, because it's in the SIMPEG realm, it's on discretize, which is the mesh, and the mesh knows the best how to display something, right? It's not,
yeah, it's all matplotlib. Yeah,
but the one who shows something is in discretize through matplotlib. Yeah.
I mean, I think that could make sense. So now talking about that there start to be too many libraries trying to do the same could be, as you say, Dieter, right? That in the end the mesh is the one that knows how to plot itself.
Subsurface doesn't necessarily know how to place these data. It just has structured and unstructured data, right?
I mean, we have the next level that is elements. I mean, we can add as much complexity as we want, but
yes, but it wouldn't have. Yeah. But like with streamlines or things like this, and then you would need the gradient, and that's things that go to the meshing utility and not really to a data storage package, I would say. But
yeah, no, it's so with this subsurface project there is two things. One is the code, another is the community that you, Dieter, are working so hard on it, because a big problem, or one of the reasons why there are so many packages doing similar things, is because we didn't know each other 5 years ago. Or,
yeah. Well, the thing is, Xarray on itself has tons of plotting utilities.
Right.
But I don't know how well they work with our data.
I know that in PyVista they want to support Xarray. So the moment you construct the meshes from NumPy arrays, they are looking to just pass an Xarray to PyVista and plot it. So that would be the ideal case. That is what Dominic was saying. That ideally, I mean, that is also an option. We really just go and start contributing to PyVista directly and do a module there of if we feel that the API is too low level, we could really just try to go there and do the API for Xarray or whatever. I don't know. It's always a bit tricky.
Yeah, because I think the problem you described, Florian, it could happen the same again in subsurface. So we would have a 2 something, and then this person leaves, and then it would get abandoned. While if it would be directly in a plotting library, that is maybe a bit less likely. Well, I'm not sure.
Yeah, so, but here is all a balance. So the plotting library has to be low level enough that is able to do everything. But when we start to be very specific in what we are plotting, then if PyVista make any change, then they break everything on top. Yeah. So.
And you're gonna have specific needs, right? You know, Florian might have he wants a slider in a separate, specific way because it's important for him, but the rest of the guys might not care for it, or something like that, right? Eventually, the plotting becomes a package dependent. So yeah, I don't know, stuff.
I don't know. It's tricky because definitely we are here people who has plotting. Yeah, I mean, there is no reason why Florian, PyGimli and GenPy could have exactly the same plotting library. Just
it's a shame that I texted Bain and he messed up dates, so it's a shame he's not here because he would maybe have some good inputs on that. But
so do you know? Sorry, Florian, do you know roughly why it's broken? Maybe that will enlighten us about where it should live and why, right? Do you know roughly why your plotting stuff is?
No, actually, I think it was some API change in the streamline function, and that's one of these examples broke down. But I haven't looked into it in more detail.
But it would be a change on the PyVista side?
I would assume so, yeah, because there was but I
package doesn't change.
Cannot pin it down at the moment.
Yeah, then there is the whole story of fixing the versions of the different packages, which that's another piece. That at the moment in subsurface, I have all the dependencies with each version, which they are starting getting old because I did it 3 months ago. you never know what is better. So if PyVista 25 was working, why are you changing? Just to do the same stuff.
Usually it's speed, efficiency. Yeah, you don't want to lose those updates, but then if you do it, then you break stuff. Yeah, I know.
Yeah.
But yeah, we would agree that it makes sense to have like that every data structure that lives in subsurface is also, there's a function to visualize it. So
yes,
I could just put in my streamlines as wells, because subsurface knows how to visualize wells, and then I have all my streamlines. No,
don't get me wrong. So with this idea I have of just taking the VTK visualization out of GenPy, it will make a lot of sense moving it closer to subsurface than it is of GenPy today. Now, I don't know if that means to just put it in subsurface itself or subsurface visualization, or we just do very good examples of how to use PyVista. That's always an option. I don't know.
Yeah, but that could also be at that early stage, it could be just the same. And if it grows too big, we could have a move to visualization out, right? I guess it wouldn't make sense to start two things.
I think that I think that the main thing that we should keep in mind today is that if we add functionality in the visualization of subsurface, I will be happy to see it, but it has to be really well contained in one sub package within subsurface, that we can just take it one day and put it in a different repo and not having to refactor the whole thing.
Yeah. Yes, also to make all the plotting packages optional. It's easier if it's just a file then. Yeah. Cool. That's really nice, Miguel. So I hope we have as much feedback as last year, which was quite good. We'll see who's coming, who's showing up. If I will say, if enthusiasm after 1 year at home is still as big to join an online conference,
I think so.
We will find out.
The trick is to choose the conferences. Don't go to all of them, because then you burn out.
That's true.
Very quickly.
But if we are able during Transform to make a couple of examples, also this communication between libraries and how simplifies complexity if they use this intermediate step, I'm sure that other people will jump in.
I mean, even if, like last year, if there would be PyGimli, Harmonica, or Verde, SimPeg, GenPy, then we would have already 4 examples, which would be a very compelling story. Yeah.
I had forgotten that we did that hackathon. But yes, we have to repeat the same. That's
we have to repeat the same, but go through subsurface and not some manual hacks. And I mean, we already have the notebooks, right? We just have to implement it in the packages and do it again. Cool. So it's in 6 weeks or so. 1, 2, 3, 4, 5, 6 weeks. Yeah. So I hope you have all reserved that weekend, 16th, 17th, 18th of April.
So it's good to know that it's official already. Has been published that the weekend, or is internal conversations?
There's probably a blog post on this one.
I believe you. This was just out of curiosity.
Well, it is then. I just wonder if it's official already or not. But yeah, I'll have to check. Yeah, you can already sign up if you want.
I have a talk actually. Matt contacted me a while ago.
Which will be the week after. Yeah.
So 17 and 18. Yeah.
It will most likely start on the 16th.
Yeah.
Well, 16th night for Europe, let's say, and day for the Americas. Basically what we did last year anyway, because we had this pre-hack meeting And they decided to do that generally because otherwise, if you start Saturday, then until the Americas wake up, it's already a half day gone for Europe. So it's kind of, yeah, it's weird to start halfway through. So we'll see how that works. And then we have two experiences and we can decide for next year.
As long as we meet at the end to show progress.
Yeah. Cool. Right. Anything else?
No, thanks Dieter again for organizing. Take us in the same room. That's good.
Thanks everyone for showing up, and see you in 6 weeks.
Yes.
See you then.
You got it. All right. Have a good evening.
Bye-bye.
Thank you, everyone.
See you all.
Take care.